Well, hi, class. This is Mr. Kinzer, and this is science. We are looking forward to studying tides today, and we're covering oceanography, as you guys know. And so we want to start in by, of course, getting our note sheet out for science. So go ahead and get your notes for science, and then you'll add these notes to the notes that you have. And you want to go ahead and label them with today's date. And so that will be either 4/14 or 4/16. Okay, so be sure that you do that and then circle the date in your notes as you always have. And so you probably noticed that we're doing everything, even though we're not in class, everything is basically the same exactly as we did before. So anything I write on this note pad that you see, be sure that you write it in your notes. But you have that added advantage to stop it. You can pause it. You can play it again. You can go back. And so there's some advantage there. So be sure you use the technology well. Let's go ahead and talk about tides today. And tides, of course, are these higher than normal sea levels that come in. And they're caused because the moon, which is a body outside of the earth, going around the earth, or the sun, which is a body way further away, 93 million miles out, they pull on the earth because they have gravity. So we know that the earth is being held by the sun's pull. And so the earth is traveling around the sun, as are all the other planets, and we are being pulled toward the sun. Now, the reason we don't get sucked into the sun by the sun's gravity is that we have this speed that we are traveling, and there's an outward pull. So as we circle the sun, this speed, which is called centripetal force, is pushing us outward and away from the sun, just like if you were to swing a rope around your head, and as you swing it around, the end of the rope, the far end of the rope, is wanting to fly out of your hand, and if you let go of the rope, it would fly out of your hand. Well, that's the same thing. If the sun's gravity, if this gravity was to stop, and instead, no longer did we have gravity pulling, the earth would just continue and to go away from the sun. It would spin out like you would if you had a rope and you were swinging around your head. So let's go ahead and mention that tides, I'm going to put a capital T, and you're invited also to put abbreviations when you take notes. Just remember how you abbreviate, and that way you can write faster. As you guys get into high school, you'll have more notes. You will, that is, if you go to a good class. A good class will require that you take notes, because taking notes helps you learn the material, and then you can study it and learn it more thoroughly. Or as you get into college and take notes, sometimes you have to write just as fast as you possibly can to get all the notes down. So tides can be abbreviated. You want to use abbreviations wherever you can. Anything that will help you take those notes. I would do it. So tides are caused, again, by the gravitational pull of the earth by the sun and the moon. So these are two bodies, and we know that there's a law of gravity says the gravity that something has is determined by the mass, and the mass exerts a pull, a gravity. So every piece of matter has mass, and so everything has some gravity. The coffee cup, and you guys can picture me holding my coffee cup right now. I've got a green cup in my hand. That gravity is a force that this coffee cup has. It's pulling things to it. So I put a paper clip up next to my coffee cup, and the paperclip is got less mass, so it has less gravity. If these two objects, my coffee cup and the paper cup or the paperclip, were floating around in space where there's no what? There's no mass because there's no matter there. It's a vacuum, and so these are floating around in space in a vacuum. And let's say I let go of them and they're 1 foot apart over a period of time, because both of these objects have gravity, and the cup has more gravity. The cup is going to pull the paperclip so that the paperclip hits the cup. I don't know if you could hear that. That was the paperclip hitting the cup. There, I did it again. Here's one more time. Listen. So the paperclip will come and it'll be connected to the cup because of gravity. So everything that has mass has gravity, and that's the principle here with tides. Now, why does tides, or let me put it this way, why does the moon or the sun pull the water on the earth instead of just pulling the earth? Why doesn't the land, in other words, why doesn't the land rise and fall with the tides? Why is it that the seas do it? And you probably know the answer to that. I know Eliana knows the answer to that, I think anyway, right, Eliana? But yeah, you guys have thought about that. Well, the reason is that the water is fluid. It moves around, and the earth doesn't. The earth is solid. It's in a solid state, and so it's just being, the dirt and the rocks are being held to the earth because of the gravity of the earth. Now, the water is also, but the water can flow around. And because it's fluid and because it's liquid, it can roll around. And so the moon and the sun can pull on it, and it'll kind of pull to one side. So I'm going to show a picture of the sun way out here, 93 million miles away from the earth. And here's the earth way out this way. I'm going to make the earth a little bit bigger just so you can kind of see it better. Here's the earth. It's way out of proportion, right? And so what happens is you have the ocean, under normal conditions. The ocean is here. It's kind of the same depth all the way around the earth. But now, because the sun is pulling this front part of the earth stronger, the water, which is fluid, bulges. It bulges out toward the sun. So you get this bulge, okay? And then, of course, it's being pulled, right? And so it kind of rolls around, and it's pulled toward that section. So you have a high tide. That's basically giving a high tide on that part of the earth. And, of course, the earth is spinning, okay? Because the earth is spinning this way. It spins from west to east, and because that's happening now, that the tide kind of rolls around, and it goes around the earth, kind of moves, kind of rolls, and so there's always a bulge toward the sun. Now, if the moon gets in the act, if the moon is over here, you can kind of see this, the moon will also pull and exert a pull, and the tide will bulge kind of on the side of the earth as well. It'll bulge out, okay? Or if the moon is not here, but it's positioned over here, well, the tides will cause the water to bulge out this way. And though the moon is only 1/6 the mass of the earth, it will pull that water particularly. Now, it's also pulling the earth. It's also pulling rocks and trees. Everything that's on the earth are being pulled toward the moon. But they're rooted. They're solid. They're heavy. They have more mass. The water tends to roll and pile up like that. Okay, so that's how tides operate. They're caused by that gravitational pull of the sun and the moon. Now, the moon's gravitational pull is greater on the earth than the sun's. Does that make sense to you guys? How come? The sun is huge. The sun is 1,000,000 times the volume of the earth. I think it's, hundreds of thousands of times the mass of the earth, but the moon's gravitational pull is greater. Well, that's because the moon, capital M, is nearer than the sun. So that absolutely makes sense. It's closer by, so it has a stronger pull, okay? Tides are highest when the sun and the moon are working together. So when they're pulling together, then they're the highest, okay? So here's an example where they're pulling together. Here's the earth, okay? And there's the sun, this massive sun, okay? So obviously the gravitational pull is very strong, particularly on this side of the earth. There's going to be a bulge. But now let's put the moon in there. Here's the moon, really tiny compared to the earth, only 1/6 the mass. Now see, the moon is also going to pull. So because the moon and the sun are pulling kind of in a straight line here, you're going to have your biggest tides. And so spring tides, that's one type of tide that we want to talk about. Spring tides occur. See if I can get that a little bit neater for you guys. There you go. They occur, there we are, during the new moon and the full moon. So at this particular time, when there's a new moon, or where there's a full moon, the full moon obviously is where you see the whole moon. The new moon is actually when the moon is on the other side and you can't see it. Okay, so spring tides, here's where an example of the new moon would be. Here's your sun. Okay, so you can't do this. Here's the earth. Okay, now here's where where the moon, when it pulls between the sun and the earth, all we're going to see is the dark backside of the moon, which we're seeing, we can't see anything. We don't see any moon in the sky. That's the new moon. And you can see what's happening here is the sun is pulling on the earth like it normally does, but also now the moon is pulling, and it's kind of got that same angle of pull. It's like it's increased the pull. So you're going to have bigger tides in the new moon situation. Now in a full moon, here's the sun, and the earth is out here. Well, here's the moon now, and the moon, it's getting the sunlight on it. So you see a full face of the moon. You get the entire circle of the moon. Now the moon is pulling this way on the earth, and the sun is pulling this way on the earth. So you're going to get high tides again. Can you tell which one you'd get even bigger? Well, I think you can sure make the point where, hey, this is the new moon would have even the higher tides. Okay, let's consider this then. When the moon and the sun, the moon and the sun are perpendicular, the gravitational pull is less. So here's the sun again, and here's the earth, and now the moon is perpendicular. What does that mean? It's at right angles to the sun. So here's perpendicular, means there's a right angle, and then this. So something's perpendicular if we have a right angle right there in this triangle that's formed here. So we've got a 90-degree angle. When this kind of situation happens, the gravitational pull is less. So be careful when you have this is a 90-degree angle here. That could happen again over here when the moon moves around. It goes around the Earth. When it moves up to this top position, you've got a 90-degree angle again right here. Okay, so there's two positions, and this produces less gravity. So less gravitational pull, less what? Tide. The tides aren't as high. So when the gravitational pull is less, the water is not pulled off the surface as much, and so you have a lower tide. Okay, so the lowest tide, the tide is absolutely the lowest when the sun and the moon pull in opposite directions, or we'll just say when they pull against each other. So in this case, they have a tie. A tide does happen, but it's the smallest tide. Okay, here's the sun. Here's the Earth. And how would the moon be if it's going to pull opposite the sun? Here's the moon, okay? So the moon is pulling. Can you see how it's pulling opposite the sun's pull? So this is going to have a high tide, but it's going to be the lowest high tide that you can have, okay? You can kind of see that. That makes sense. Okay, so make sure that you kind of visualize this, and then as you study this, just kind of put this on paper, take a look at it, make sure that you understand how the tides work as the moon goes around the Earth, okay? Now, the next thing we want to talk about are neap tides. So, neap tides. These occur during the first quarter and the last quarter of the moon. Oops, let me say quarter moon. So this is, they occur during the first quarter and the last quarter moon. So as an example of a neap tide, we would have the sun, of course, pulling again, massive pull on the Earth. So we have that pull. Okay, that's always there. But now, gravities from the sun and the moon are also pulling against each other in this one. So here's our first quarter moon. Here it is. And we're going to have, the pull this way. Or if we do our last quarter moon, we have the pull this way, the pull of the moon on the Earth, right? And so when that happens, we've got these bigger tides toward the moon than we do toward the sun when they're arranged in this orientation. These are called neap tides. And I'm going to give you a worksheet, which I'll be sending, and we have these two high tides, two neap tides that result in this orientation. So I'll send you a worksheet that shows you this really clearly. But go ahead and sketch this. See if you can see and understand it, and really kind of begin to kind of get it in your head a little bit, even before you get this this worksheet. Okay, so there are typically 2 tides a day. Boy, let's see if I can spell that one. Here we go. Typically. It's typical. There are 2 tides per day. And you can kind of see why. And if you're living, let's say, on the coast and you have the ocean right there, let's say you live in Los Angeles or Houston or New York City, there's going to be 2 times a day when there's a pull that's going to cause high water. And obviously when the sun is directly overhead at noon, right, that's going to have a pull when the sun is directly overhead. So it's going to pull. That's going to be one time. But then the earth turns, and when you get all the way around to the other side at midnight, there's another tide. And so you have that high tide both at midnight and at noon each day. And it varies a little bit depending on where you are on the surface of the earth, but basically it's that same idea that when the sun is up and it's overhead, the highest, that's when you're going to have the high tide. And that 12-hour period later in the day, which would be at night, you're going to have that high tide as well. And so tides are constantly causing the ocean to move around. One of the things that a tide does is it flushes because the ocean comes up and it goes up rivers a little bit. There's a movement of salt water that goes up the rivers a little bit, a few miles. It goes up and it brings in nutrients. And then, of course, the whole ocean level moves up, and so those rocks and beaches get submerged by the ocean. Some of you guys have been on the beach. You get up in the morning, you go on the beach, and the tide has gone out. And there's all these shells and stuff that are up on the beach because the high tide at midnight or so the night before left them up there. So there's a flushing, there's kind of a cleansing action there. And so things are carried out and brought up. And so it's kind of a nice situation. There's oxygen that's added to the ocean because the waves are moving up and they're crashing up higher on the beach. So there's an oxygenation of the water. So there's a lot of things that are happening. There's as the waves get up on the beach at high tide, they carry a lot of what they call detritus, which are little broken up twigs and grass and plants. And of course, fish feed on that. So all that detritus is brought out to the ocean, and the clams and the fish, the starfish, everything that's in the that littoral zone we talked about where the waves are, all of those little animals feed off of this detritus. So it's a real productive area. So that area right there on the beach. So we want to remember, as we remember our diagram of the beach, we have this berm and then there's this slope. And right here, here's the ocean level or sea level. Right in here where this is the beach, this section right here. The tide goes up. When it's high tide, it'll be up that high. When it's low tide, it'll be back, to the lower area. So this area here it's affected by the tides, and it washes material out, detritus. And so this area, which is called the littoral zone, is very productive. This is where most of the fishing is. This is where most of the plants are. Plus, you guys remember sunlight is making it down here all the way to about where it's 600 feet deep on the edge of the continental shelf, where now the shelf drops off and becomes the slope. Okay, so this, how far does the sunlight come in? Well, the sunlight filters down about 200 feet. So this is the most productive area. This is where all the algae are. The fish hang out there because they can eat the algae. And of course, this zone up here, this littoral zone, You're getting it oxygenated. The waves come in, they crash, they come back, they move in again, they crash, they come back. So this whole area in here is great for fish. They love being in that area. This is where you go, you're skin diving. You guys would go get your skin diving suit on, and you'd see big whales that come in because they're going to feed close to shore. So this is really great. So it's really a great area to be skin diving and enjoying that. So we're going to go to our next tape. So I'm going to stop this one and we'll go to part 2.